Hello and welcome to helpyourmath.com. In this video, we are going to talk about the domain and period of sine and cosine functions. And I should also say, we're also going to talk about the range because, spoiler, the domain of sine and cosine functions is all real numbers. But what is the range of these functions? So with sine, you can plug in anything you want. You can take sine of 3. You can take sine of 3 pi. You can take sine of 3 pi over 19. But what are the possible outputs that we could get based on the input that is any real number? And for that, we're going to turn to our good friend, the unit circle, because the unit circle gives us all the possible sine ratios and cosine ratios. It's all contained right here in this beautiful unit circle. And so we might recall that sine corresponds to the y values. And if we go around the unit circle and look at all of the possible y values, we have 0, a half, root 2 over 2, which is, the square root of 2, which is going to be 1 point something divided by 2. The square root of 3 divided by 2 will be 1 point something divided by 2. Up here we have 1. Over here we just have more of those same numbers, the negatives, and down here we have -1. So it turns out for sine that the range, the only possible outputs that we could have are between -1 and 1. And for cosine, where we look at the x values, it's the same thing. The largest x value that we see is 1, and the smallest is -1. So we can say for both sine and cosine that the range is going to be the numbers between and including -1 and 1. And that's all we get, right? And we can use the unit circle because we can always find angles that correspond to angles that are on the unit circle. We call those coterminal angles. So previously we looked at, I might have said, find cosine of -pi over 3. Indicates that we're going clockwise. And if I go down pi over 3 units, I'm down here, and it corresponds to, on the unit circle, 5 pi over 3. So because they have the same terminal side, they share that point that's on that terminal side, and then they share the same cosine value. So the cosine of -pi over 3 would be the same as cosine of 5 pi over 3, which would equal 1/2. Because of this trend where I could either go down or all the way around, we say that because they repeat each 2 pi, which would be a complete circle, radians, that they are periodic functions. And we can conclude that if we have some value on the unit circle and we know what sine of that value is, that's going to be the same as any other value that's 2 pi radians different, a multiple of 2 pi radians apart. So sine of t, where t is some angle on the unit circle, would equal sine of t plus 2 pi times n, where n is some integer. So it has to be an integer that's, -3, -2, -1, 0, 1, 2, 3, ... in both directions. And the same can be said for cosine. We can say that cosine of some angle on the unit circle is equal to cosine of t plus 2 pi times n radians. We can rewrite a radian measure given outside of the unit circle as a sum of a value within the unit circle, which I'm calling t, plus 2 times pi times n. Then it will equal just that value of the trigonometric function at t. Now, I like to do this going back to a previous section where I use coterminal angles, because every angle will be coterminal with some angle in the unit circle. And once I know that value, then I can just use the unit circle to help me. So let's look at some examples. First up, we have sine of 11 pi over 4. I see that the biggest over 4 ratio that I have is 7 pi over 4. So we do see that 11 pi over 4 is outside of the unit circle. But I might just find what angle is coterminal with it. Since 11 pi over 4 is bigger than what I'm looking for, I'm going to subtract 2 pi, right? I'm going to take away a circle from 11 pi over 4. And when I subtract 2 pi, because 11 pi over 4 is a fraction, I know that I need 2 pi to also be a fraction of denominator 4. So I need to multiply it by 4 over 4. Now what I have is 11 pi over 4 minus 8 pi over 4. And now I know that 11 pi over 4 is coterminal with 3 pi over 4. And 3 pi over 4 is going to be right here, right? We see it right here. So 11 pi over 4 would just be that complete circle. There's the 8 pi. Here's the 3 pi over 4 more. And it's asking for sine. So what's sine on that terminal side? Sine is corresponding to the y value, and we get root 2 over 2. For the second one, cosine of negative 13 pi over 3, negative is going to be too small for my unit circle. So I'm going to add at least one 2 pi to this, maybe even more. Let's see how many we're going to need. I have 13 pi over 3. I want to add to it at least one 2 pi over 1. Before I start anything with adding or subtracting, I do need that common denominator. Here, the common denominator will be 3 because the other one has a denominator of 3. That gives me 6 pi. 6 pi is going to be too small, so I have the option of either just right now adding on another 6 pi or just kind of like doing this one step at a time. Since we're getting used to it, I'm just going to do this one step at a time so we get used to it. But we do just want to remember that as I go through this, that 6 pi over 3 is the same as 2 pi. So when I add negative 13 pi over 3 plus 6 pi over 3, initially I'm going to get negative 7 pi over 3, which is still negative and therefore not on the unit circle. So I'm going to do it again, negative 7 pi over 3 plus another 2 pi, another 6 pi over 3. Oh, so close. I get negative pi over 3. I need it again because I mean, either you can use negative pi over 3 because maybe you feel comfortable with it, or you're like, no, I want to see the number on the unit circle. In which case I would say negative 1 pi over 3. Sorry, it's getting low on my screen, so it's really hard for me to write down here. Plus 6 pi over 3. And, oh, gross. And I get 5 pi over 3, which is on my unit circle. So now I know that cosine of negative 13 pi over 3, because it shares a terminal side with 5 pi over 3, the ratio measure is the same for either angle, right? Negative 13 pi over 3, I would be going down. Where's 5 pi over 3? It's right there. I would be going down and doing one full circle, down, doing another full circle, and I think I even have to do one more, right? I added it 3 times. I added it a whole bunch to finally get to that 5 pi over 3. I'm looking for cosine, I'm looking for x, and I get 1/2. And for the last example on this page, we have cosine of 25 pi over 6. And again, we want to figure out what this corresponds to in the unit circle. So we're going to say 25 pi over 6 is equal to some number in the unit circle plus 2 times pi times n. Since we have that denominator of 6, I want to try to pull out as many 2 pi's as I can from 25 pi over 6, keeping in mind that 2 pi would be the same as, let's see, that would be over 1 times 6 times 6. That's the same as 12 pi over 6, right? So that would be the equivalent of 2 pi. So how many 12 pi's can I pull out from 25 pi? And I think I can do 2 pi's, right? Because 2 pi's, if I multiplied this by 2, I would get 24 pi over 6, which gets me just under 25 pi over 6. So I'm going to do 2 pi's. And that would give me, so that would be 4 pi, but in terms of 12 pi over 6, that would give me 24 pi over 6. And I'll subtract that from what I'm given, 25 pi over 6 minus 24 pi over 6. And it turns out I end up with pi over 6. So pi over 6 is my t value, right? We can take this 25 pi over 6 and rewrite it as pi over 6, that t, plus 2 pi, and I pulled out 2 pi's. So that means that 25 pi over 6 is the same, or would have the same cosine value as pi over 6. Pi over 6, I'm getting crowded here, so I'm just going to focus on pi over 6, which is right here. Cosine is x, so my answer would be root 3 over 2. So far, so good. Let's try 3 more. For these last 3, we have sine of 17 pi over 2. And again, we want to, for each of these, rewrite it as t plus 2 times pi times n. In this case, because what we're working with is a denominator of 2, I want to think about my 2 pi's as something over 2. So 2 pi over 1 is what over 2? That would be times 2. And I'm looking at 4 pi's. So the question is, how many 4 pi over 2's can I get in 17 pi over 2? And I think there are 4 of them, right? There's 4 2 pi's, because if I multiplied 4 pi over 2 by 4, I would get 16 pi over 2. Okay, so I want 4 of these 2 pi's, which again, I'm going to use my 4 pi over 2 and get 16 pi over 2, right? Because that would be the same as 8 pi. Now, I'm going to take the angle measure, 17 pi over 2. I'm going to subtract 16 pi over 2, and I end up with pi over 2. So what that tells me is that sine of 17 pi over 2 has the same terminal side as coterminal to sine of pi, or to pi over 2. That would just be 4 loops around, right? So I would go 1, 2, 3, 4, and stop right there at pi over 2. I'm looking for sine, and sine is 1. What about sine of negative 25 pi? All right, so we have a negative. We want to rewrite negative 25 pi in terms of some number that's on the unit circle, some angle that's on the unit circle, plus 2 times pi times some integer. Since negative 25 is negative, I know that n is going to be some negative number. And if we think about this, we want more than what we have. And this one's kind of nice because we don't have a fraction, but it looks like I'm going to need 13. I'm going to do 13 rotations to get to negative 25 pi. That's kind of crazy. Because if I set n equal to 13, that would give me 2 pi times 13, which is 26 pi. And if I add negative 25 pi plus 26 pi, so 13 rotations, I end up with, just pi. So that means that sine of negative 25 pi will be the exact same as sine of pi because they share a terminal side. Well, sine of pi, that's just over here. Sine is the y value, and y is 0. And in our last example, we have cosine of 32 pi over 3. So again, we have 32 pi over 3, and we want to figure out what values on the unit circle, plus all of these, extra rotations that we would do. I want to think about 2 pi with a denominator of 3, so that's 2 pi over 1 equals what over 3? Well, I would need to multiply by 3 over 3, and I get 6 pi over 3. So now I'm thinking about how many 6's can I pull out of 32, right? I don't want to just keep subtracting 6 pi because that's going to take quite a few many times. It looks like I could do 5 because that would give me to 30. So I want 5 of these 2 pi's, but remember I'm calling 2 pi 6 pi over 3. So 5 times 6 pi over 3 is 30 pi. And again, that works out because that's 10 pi, and 30 divided by 3 is 10 pi. And so I'm going to take that 30 pi over 3, and I'm going to subtract it from the given angle, and that gives me 2 pi over 3. Okay, so again, what this means is that the angle we're given, 32 pi over 3, is coterminal with 2 pi over 3. Why do we like 2 pi over 3? Because it's on the unit circle. And once it's on the unit circle, I can pretty quickly identify what cosine of 2 pi over 3 is because I just need to figure out where 2 pi over 3 is and look at the x-coordinate associated with it. So I'm looking for 2 pi. Oh, it's right there, right? There's 2 pi over 3. And the x associated with it is negative 1/2. And so any angle that's coterminal to 2 pi over 3 will also have a cosine of negative 1/2. This has been the definition of the domain and the period of sine and cosine functions. Thank you for stopping by.